So now that we've solved for our angles, the next thing we need to do is solve for our reactionary forces. And we got a few. We got a reactionary force at joint A in the y direction, or ray as I like to call it. And then we've got a reactionary force here at joint A in the x direction, which I call rax. And then of course on the other side we've got a reactionary force at joint C in the y direction, or Ricky. And of course, since this is a roller, we don't have an x component or an x reactionary force at joint C. And so let's go ahead and start solving for these reactionary forces. And I like to start with the x just because it's a little bit easier. We say the sum of all forces in the x direction equals 0. And okay, what do we know? Well, we know we got 60 pounds here going to the right at joint D. And the only other x-word force on this entire truss would be rax. Okay, so we'd say plus RAX, or reactionary force at joint A in the x direction. And since I know these add up to 0, then I know they have to be going in the opposite direction. I can see very clearly from my problem that 60 pounds is going to the right. Therefore, my reaction has to be going in the opposite direction, to the left. So when we drew this here going to the right, we were wrong, so we go ahead and erase that, and we just redraw it and say it's rax is going to the left. And we can even say, okay, well, I'm going to set my leftward forces equal to my rightward forces, therefore rax equals 60 pounds. So next, let's go ahead and start solving for the sum of all forces in the y direction. We'll set that equal to 0 as well. And the first one we know, we got 540 pounds going downward. Okay, and we also know, well, we got Ray and Ricky, so we'll say plus Ray, or reactionary force at joint A in the y direction, and we'll add Ricky as well. And we know these three forces have to add up to 0. And we can also look and say, well, Ray is going upward. We can see that Ricky would be going upward as well, most likely anyway. And then we can say 540 is going downward. And any time you assume one's going up, or one's going down, or one's going to the left, or one's going to the right, or even compression and tension, if you assume it's going a certain way and then you get a negative answer later, you know you got it backwards, and you just reverse it in your free body diagram. So I'm going to go ahead and set my upward forces equal to my downward forces. So let's go ahead and write that out. We'll say Ray plus Ricky, the right color here, plus Ricky, and we'll say that is equal to 540 pounds. And as you can see, we don't really have enough information to solve for Ray or Ricky, but there is a way to solve for these, and it's through the moments. Right? So you might recognize, well, here at joint B, there is going to be a moment. It's going to go down with our force at joint B, and then towards our pin over here at point A, and we'll call that one moment B, since it's the moment at point B. And you'll also notice that there is a moment at C, and so that's going to follow Ricky, and it's going to go up and then towards our pin, which should be up and to the left, and that's moment C, okay? But then you might think that's all of them, but really there's an extra force up here at D that's a distance from our pin, and so that's going to be our last moment. That is moment D, and it's going to go to the left and then downwards towards our pin. So let me go ahead and draw this a little bit better here. It's going to go to the left, or I'm sorry, to the left, to the right, and then downwards towards our pin, and that's moment D. And we know that all three of these moments have to add up to 0. So let's go ahead and use that. The sum of all moments equals 0. And then we'll set that equal to our moments. Let's go ahead and write these out. We got moment B here. We'll say moment B, and we'll add that to moment C, and then moment B plus moment C, and moment D as well. Okay, so moment D. And I know all three of these moments have to cancel out, because if they weren't, well, this bridge would probably be flopping over one way or the other. And if we look, we can see moment B here is going clockwise, which is important to note. Moment C would be going counterclockwise if you follow the arrow. And then moment D, if you follow the rotation, would be going clockwise. And if all of these add up to 0, then that means my clockwise moments are going to equal my counterclockwise moments. So I can rewrite this equation to say, well, moment B plus my other clockwise moment, which is moment D, equals moment C. And so let's go ahead and rewrite this. We can rewrite moment B as its force times its distance. Well, its force at moment B is 540 pounds. We'll multiply that by its distance from the pin. Well, moment B is 3 feet from our pin. And then we can add that to moment D, which we can see the force at moment D is 60 pounds. And we'll just multiply that by its distance. And remember, the only distance we care about is the perpendicular distance here, which is 5 feet. And we'll set that equal to moment C, which, as you'll notice, the force is Ricky, the reactionary force at joint C in the y direction, multiplied by its distance, which is not 5 feet, but the distance from the pin, which is 5 plus 3, which is 8 feet. And so next we can simplify this. We'll just pull out our calculator. We'll say, what is 540 times 3 feet? So we get 1,620. Let me get the right color here. We get 1,620, and then the units would be foot pounds or pound feet. Doesn't really matter how you write it. And then we'll add that to, well, what's 60 times 5? Pull out our calculator again. We'll say, what is 60 times 5? And we get 300 foot-pounds. Move the right color here. Let's say 300 foot-pounds. And then we'll set that equal to, again, well, Ricky times 8 feet. And actually, we can simplify this again. I can see very clearly that this is going to add up. It's just going to be 1,920 foot-pounds. And that is equal to, again, well, Ricky times 8 feet. And we get the right color here. 8 feet. And so to solve for our reactionary force at joint C in the y direction, we'll just divide by 8 feet on both sides. So 8 feet, feet cancels out, 8 feet over here cancels out. And so what is 1,920 divided by 8? Well, 1,920 divided by 8 is 240. And so what do we get? We get Ricky equals 240 pounds. And then we can just plug that in over here. We would say Ray plus, let's write the whole thing out, plus 240 pounds equals 540 pounds. With the right color here. 540 pounds. And then we would just use simple algebra to solve for Ray. What will we get? Well, we clearly get Ray equals 300 pounds.